So I want you to picture something. You're driving down the highway, and this massive, heavy-duty 18-wheeler is just flying past you.
Right. Doing like 65 miles an hour, kicking up all that wind.
Exactly. And, if you're like most people, you probably just see a giant metal box carrying your online shopping.
Yeah. It's just a big truck taking up the lane.
Right. But here's the thing. The most expensive, the most unpredictable part of that massive delivery truck, it actually isn't the engine.
No, not at all.
It's not the high-tech transmission either, or the steel chassis.
Yeah.
Over the lifespan of that vehicle, the most relentless drain on a fleet's bank account comes from, well, the black circles of rubber touching the road.
And all these hidden metal components grinding against each other just to keep them spinning.
Exactly. You're actually looking at a highly sophisticated, multi-billion-dollar technological ecosystem. And it's fighting this constant invisible war against physics and friction.
It really is. And it's an ecosystem that operates completely out of sight for the average driver, but it's literally the structural foundation of modern life. Yeah.
I mean, we focus so heavily on supply chain logistics, right? Like where the cargo is, what ship it's on, which warehouse is holding it.
Right, tracking the package on your phone.
Exactly.
Yeah.
But none of that matters if the physical machine moving the cargo can't actually survive the journey.
That is such a good point.
The underlying components keeping those trucks safely in motion have undergone this massive fundamental shift. And honestly, most people are completely unaware of it.
Well, welcome to our deep dive. Today, we are pulling from the 2026 report, Wheels of Commerce, the 2026 Trucking Supply Ecosystem.
It's a fantastic report.
It really is. And our mission here is to explore how the tire and heavy parts supply market has evolved. It's moved way past the simple transaction of just, selling replacement rubber and metal.
Right.
We are looking at a sector that has completely transformed into a high-tech, predictive service industry, one that literally ensures the survival of global commerce.
Yeah, without it, everything stops. Okay, let's unpack this. Because to truly understand the technology, we have to look at the sheer, staggering scale of the market.
The numbers are wild.
They really are. We are talking about a global truck tire market exceeding $48 billion.
Just for the tires.
Just tires. And then the heavy truck parts market surpasses a massive $119 billion.
Yeah.
So together, that is a hidden engine worth over $167 billion.
What's fascinating here is the structure of that $167 billion. That's where the real story lies,
How so?
Well, you have the OEM side, right? The original equipment manufacturers. Those are the suppliers working directly with truck brands to build brand new vehicles.
Okay, the factory floor stuff.
Exactly.
Okay.
But the absolute behemoth of this industry, the segment generating just a relentless, continuous revenue, is the aftermarket.
The parts and tires needed after the truck leaves the dealership.
Right, because a commercial truck can drive upwards of 100,000 miles a year.
100,000. Wow.
Yeah, and that level of utilization demands a continuous heavy flow of replacements. Tires, brakes, suspension joints, filters, all of it.
I have to admit, when I was looking at the numbers in the report, my initial assumption was completely wrong.
How so?
Well, I assumed the real money, the real leverage in the trucking industry was in selling the actual trucks. I mean, they are $500,000 machines.
Right, they're huge investments.
But looking at the dominance of the aftermarket,
Yeah.
it seems like the classic printer and ink business model.
Oh, that's a really good way to look at it.
Yeah, because the truck itself is just the printer. It's the necessary vessel. But the aftermarket parts, the brake pads, the heavy axles, the tires, those are the wildly lucrative ink cartridges.
Yes.
You could delay buying a new printer, but if you want to print, you have to buy the ink because of those constant maintenance cycles.
The economics of the printer and ink analogy hold up perfectly, but the physical reality of the aftermarket is, much more intense.
What do you mean?
It's more like trying to replace the foundation of a house while it's moving down the interstate at highway speeds.
Oh, wow. Yeah, that's a terrifying image.
Right. And because the stakes are so high, we are seeing a massive turf war over who provides that ink. For decades, the tire segment was dominated entirely by legacy giants.
Like Michelin, Bridgestone, Goodyear, Continental.
Exactly. They built their empires on extensive dealer networks and premium engineering. But the 2026 report highlights that they are currently fighting a brutal battle for market share.
Against who?
Against highly agile, low-cost manufacturers emerging from China and India. They're gaining a lot of ground with really cost-effective alternatives.
And it's not just tires, right? On the parts side, you have heavyweights like PACCAR parts, LKQ heavy truck, Meritor and Otterman, they supply everything from axles to electronics.
Yeah, and the distribution of these parts has completely fractured.
Fractured how?
Well, fleet managers aren't just calling up a local dealer anymore. They are using direct contracts, sophisticated online marketplaces, and mobile service providers to source parts.
So they're optimizing for cost, speed, and availability at this microscopic level.
Exactly. And speed and availability usually win out in that equation. Because a truck parked waiting for a part is not just failing to generate revenue,
Right.
it's actively damaging the shipper's contract metrics.
So this intense pressure to keep the wheels turning has fundamentally changed the physical products themselves. I mean, fleets are desperate to slow down that expensive replacement cycle.
They have to, which means they need cutting-edge technology.
Which brings us to the actual hardware, the physical tires on the tarmac. The report mentions that radial tires now account for over 87% of commercial usage.
Yeah, overwhelmingly replacing older bias tires.
But what is the actual physical difference there? Like, why does the internal geometry of a tire dictate whether a global logistics company turns a profit?
It all comes down to friction and heat. In an older bias ply tire, the internal structural cords run diagonally. They crisscross each other in these overlapping layers across the entire tire. And because of that interconnected structure, when the tire rolls and the tread hits the road, the rigid sidewall has to flex.
Right, to observe the bump.
Exactly. But that flexing forces the tread to squirm and rub against the pavement. All that internal friction generates an enormous amount of heat, and heat destroys rubber.
So radial tires change the physics entirely.
They did.
So how are the cords aligned in a radial tire to stop that squirming from happening?
The internal cords run straight across, radially, from one rim bead to the other, almost like strikes on a zebra.
Oh, okay.
And then, underneath the actual tread, there are rigid steel belts holding everything flat.
So it separates the duties.
Precisely. The sidewall can flex independently to absorb bumps without pulling and distorting the tread on the road.
Less squirming means less friction.
Less friction means significantly less heat, drastically better fuel economy, and a tire that survives tens of thousands of miles longer.
Okay, here's where it gets really interesting. Because the real revolution in the 2026 report isn't just about how the internal cords are arranged.
No, it's not.
It's about data. We are talking about smart tires. Tires equipped with real-time sensors monitoring internal pressure, the temperature of the air chamber, and the physical wear of the tread itself.
Yeah, to enable predictive maintenance.
When I was reading this, it sounded like a wearable fitness tracker for vehicles.
That's a great analogy.
Like a smartwatch.
Yeah.
Instead of waiting for a heart attack, a massive blowout on the highway, the truck's smartwatch warns the fleet manager that the tire's blood pressure is too high.
That is exactly what it's doing.
But here's what I don't understand about the mechanics of that.
Yeah.
How do you put a delicate data-transmitting electronic sensor inside a pressurized 200-degree rubber drum that's taking violent impacts at 65 miles an hour?
It sounds impossible, right?
It sounds like trying to broadcast a Wi-Fi signal from inside a washing machine on the spin cycle.
The engineering required to make a smart tire function reliably is extraordinary. You can't just, glue a sensor to the wheel.
Right.
Manufacturers embed the sensors directly into the inner liner of the tire during the vulcanization process, or they use highly specialized heavy-duty patches that bond with the rubber at a molecular level.
Wow.
And these sensors are built to withstand extreme centrifugal force. They use low-energy communication protocols, often communicating with a receiver hardwired into the wheel, just a few inches away.
And then that relays the data to the truck's central computer.
Exactly.
And the report specifically highlights the results of this tech. It notes a massive drop in roadside tire failures for fleets adopting these sensors.
It's a game changer.
Because the fleet manager sees a temperature anomaly on the dashboard, like 3 days before the tire actually gives out.
Yeah, right. So they route the truck to a bay, swap the tire during a driver's mandatory rest period, and completely eliminate the breakdown. If we connect this to the bigger picture, that shift from reactive repair to predictive maintenance alters the entire risk profile of shipping.
It really does.
But it also serves a dual purpose. It ties the tech back to sustainability. By running tires at the mathematically perfect pressure at all times, fleets extend the lifespan of the casing.
And that stabilizes supply chains and meets environmental goals.
Exactly. The longer you keep a tire viable, the more successful the retreading process becomes.
Okay, wait, we need to pause on retreading. Because I think a lot of people outside the industry, misunderstand what that is.
They definitely do.
When you say fleets are taking old tires and bonding new rubber to the old casing, I immediately think of those massive, terrifying strips of blown-out tire debris you see littering the shoulders of the highway.
The gators.
The gators, yes. Isn't retreading inherently dangerous if the glued-on tread just rips off at high speeds?
That is probably the most common myth in the trucking world.
Wait, really?
Yeah, the overwhelming majority of the tire debris you see on the highway does not come from failed retreads.
No.
No, it comes from virgin tires that were chronically underinflated, built up massive internal heat, and suffered a structural casing failure.
Oh, wow. I had no idea.
Retreading, when done in a modern certified facility, is not just slapping glue on rubber to save some cash. It is a highly controlled process.
So they're essentially remanufacturing the tire.
Correct. A commercial tire casing is engineered to outlast its original tread by hundreds of thousands of miles.
Okay.
Once the contact patch wears down, the casing is X-rayed. They scan it for microscopic structural flaws using this tech called shearography.
That sounds intense.
It is. If it passes, they buff off the remaining old rubber. They apply an uncured layer of new rubber tread and then place the entire unit into a curing chamber under intense heat and pressure.
So it fuses together.
Yes, the molecules cross-link. The new tread and the old casing become a single, contiguous piece of rubber again.
That's amazing.
It's structurally sound, it drastically reduces the raw petroleum needed to build a tire, and it saves fleets a fortune.
But here is the tension I found while reading the report.
Okay.
If smart sensors are preventing blowouts, right, and radial construction is reducing wear, and retreading is extending the life of the casing multiple times over,
Yeah.
you would think the aftermarket revenue would be shrinking because fleets are buying fewer new tires. Yet the report shows the market is exploding.
It is.
What is driving that contradiction? Why the sudden desperate need for hyper-efficiency?
The contradiction is resolved when you look at the macro-level demand drivers. The sheer volume of freight has increased exponentially.
Because of e-commerce.
Exactly. Driven by the relentless pace of modern consumerism. Consumer expectations have compressed delivery windows from weeks down to hours.
We want it now. If I order something on a Tuesday, I expect to see it on my porch by Wednesday afternoon. And I rarely think about the physical machinery that has to, break the speed limit to make that happen.
And the toll that takes on the physical machinery is immense. Faster deliveries mean increased truck utilization, which leads to faster wear and tear.
Because the trucks are always moving.
Right. Historically, a truck might run during the day and cool down at night. Today, slip seating is common.
Slip seating.
Yeah, one driver finishes their shift and another driver immediately gets in. The truck never cools down.
Oh, man.
The tires are subjected to continuous punishing heat cycles and heavier loads. So even with the advanced radial technology and smart sensors, the accelerated usage means the fleet is burning through the lifespan of those components faster in real time.
Even if they are getting more miles out of them overall.
Exactly. Plus, you have fuel costs driving demand for low rolling resistance tires.
Right. They have to squeeze every mile out of a gallon of diesel.
Mm-hmm.
But amidst all of this pressure, the most fascinating shift in the 2026 report isn't about the technology of the rubber.
No, it's the business model.
It's about how the rubber is sold. The industry is rapidly shifting to tire as a service. When I read the details of this, it completely reframed how I view logistics.
It's a huge pivot.
Wait, so fleets are no longer buying tires?
No, they're not. They are moving away from product sales to service-oriented models.
It's essentially like subscribing to Spotify. Instead of buying CBs, you're just paying for the stream of miles rather than owning the physical rubber.
That's exactly how it works. The transition from a capital expenditure to an operational one is reshaping fleet finance.
So how does it actually function on the ground?
They pay a set rate per mile driven. In exchange, the tire manufacturer or a specialized mobile service provider retains ownership of the tires.
So they install the smart sensors.
They install the sensors, monitor the real-time data, manage the predictive maintenance algorithms, and dispatch mobile service units.
Oh, to do on-site repairs and swap out the tires before the tread reaches a critical minimum?
Yes, and that reduces driver downtime and completely changes the financial structure of logistics.
It perfectly aligns the incentives. In the old model, a manufacturer made money when a tire wore out and you had to buy a new one.
Right.
Now, the manufacturer is responsible for the replacement cost. Suddenly, They want that tire to last as long as structurally possible.
Exactly. And the mobile service providers will drive out to the fleet yard at 2 in the morning, find the truck pinging a low tread alert, and change the tire while the driver is asleep in the cab.
Zero operational downtime.
It creates a highly optimized closed-loop system, but this tightly wound pay-per-mile ecosystem has serious vulnerabilities.
Right. The pay-per-mile tech ecosystem sounds flawless on paper, but we have to transition to the harsh realities of global economics.
Because a system optimized for perfect efficiency is highly sensitive to external shocks.
And this entire high-tech ballet still relies on raw physical materials. It's influenced by the cost of natural rubber, transportation costs, international tariffs, and, currency fluctuations.
The report does mention a slight deflationary pressure in 2026.
Due to manufacturer promos, right?
Right, but volatility remains high due to oil prices and supply chain disruptions. Those promotional discounts do not mask the persistent threat of those disruptions.
Which is why fleets are trying to lock in long-term supply contracts.
And aggressively diversifying where they source their parts. Because if a port strike or a geopolitical event delays a shipment of specialized sensors or brake valves, the entire predictive maintenance model falls apart.
You cannot dispatch a mobile repair unit if the warehouse is empty.
Exactly.
And that desperation introduces another, much darker vulnerability the report touches on: counterfeit parts.
That's a massive issue in certain regions.
When an authorized dealer is out of stock, and a fleet manager has a truck bleeding money sitting in a bay, they might turn to a gray market supplier online.
And the part arrives, it looks identical. The stamped logo matches.
But the internal metallurgy of that brake caliper is vastly inferior.
Yes.
So what does this all mean? Let's bring this entire discussion directly to the listener's doorstep. If you're just going about your day, waiting for a crucial package to arrive, say vital medication or parts for a business, how does a supply chain vulnerability, like a counterfeit part or an oil price spike, actually impact you?
This raises an important question, and we can trace the cascade effect of that single failure. Let's say that counterfeit brake component heats up under a heavy load and fails prematurely.
Okay, the truck is stranded.
The truck is stranded. Immediately, the specific load of goods it was carrying is delayed, missing critical fulfillment windows, but the ripple effect is much wider.
Because brokers and shippers depend entirely on supplier reliability.
Exactly. That truck is now down, so it misses its next scheduled pickup. The freight broker handling that next load now has an empty dock.
And they have to scramble to find a replacement truck at the last second.
Finding an emergency replacement truck comes at a massive premium.
So it directly impacts delivery timelines and contract performance.
And those accumulated emergency costs are not simply absorbed by the corporations. They are baked into the final retail price of the goods.
So it ultimately affects the cost and availability of the goods we rely on every single day.
The reliability of that ground-level tire and parts ecosystem directly dictates your reality as a consumer.
It is a massive, incredibly taut, invisible web. And the moment one tiny strand snaps, the vibration is felt all the way down to the consumer level.
It really forces you to view the infrastructure of our economy differently.
It definitely does. Let's briefly recap the journey we just took. We started this deep dive looking at a hidden $167 billion plus market.
The trucking ecosystem.
Right. And we saw how it evolved from selling simple rubber into a high-tech, predictive tire-as-a-service industry, all of it driven by relentless e-commerce demands.
From friction-heavy bias tires to efficient radial construction and smart sensors.
So, to our listener, the next time you are on the highway and you see a delivery truck, don't just stare at the metal box. Look down at the wheels.
Realize what you're actually looking at.
You are looking at real-time data nodes actively keeping the economy alive.
But, as we look past the 2026 data, the report leaves us with a final thought to ponder. A critical physical puzzle that has yet to be solved.
Building off that brief mention of electrification-compatible components, right?
Exactly. The world is rapidly shifting toward electric trucks. Government mandates and sustainability goals are pushing heavy electric commercial vehicles.
Right.
But there is an inescapable reality regarding battery technology. Electric trucks are significantly heavier than traditional diesel trucks.
Because of the massive battery packs required to haul freight?
Yes. Adding thousands of pounds of dead weight to the chassis, and that added weight, combined with the instantaneous torque of electric motors, is going to increase tire wear exponentially.
The physical rubber will degrade much faster.
Which leaves us to consider, as the logistics industry forcefully pivots toward heavier electric vehicles, Will the futuristic tire as a service business model financially survive the sheer physics of heavier electric vehicles shredding through tires faster than ever before?